There's a willingness to learn. There's a need to learn.
It's not easy all the time, but when I find something really interesting, that would make my day.
These are the people that are going to be responsible for humanity's further existence on the planet.
From all different countries, with all different backgrounds, people bring their expertise, they mix here together and produce something very new and interesting.
Each individual person comes from somewhere else, but we're all really friends, like truly friends.
Every day is not a discovery, but eventually you come to something completely new.
Dalhousie is one of the leading research-based universities in Canada, and we have an excellent team at Dalhousie for the kimberlite studies.
Kimberlites are very important and very interesting because they are the deepest magmas that reach the surface of the Earth, and therefore they provide us with the information about the processes and what happened in these deep mantle regions.
We subject geologic materials to high pressures and high temperatures, trying to emulate what actually occurs at depth within the Earth. By doing this, we can study how different elements will distribute themselves throughout the different phases as a magma cools.
My work looks at how much carbon dioxide the terrestrial biosphere, so plants and soils, is able to sequester. And it looks at how we model this and how these models eventually estimate this carbon sink and how this ultimately impacts climate change.
I specialize in structural geology and tectonics. These are the geological disciplines that deal with deformation of the rocks. We study these deformations from the molecular scale, really from the crystal lattice level to the mountain range level.
This one here.
We have people working on experimental petrology, we have people working on cosmogenic nuclides, we have seismology, tectonics. It's a very broad, diverse group.
What we do is active and passive source seismology, with the difference being that active seismology, we have actually sources of the waves that we send into the ground, and for the passive seismology, we just listen to natural sources like the earthquakes.
I study the seismic activity in different areas, and I find their cause, their effect, and their potential hazard.
We're not just all about theory. We really focus on bringing students out into the field. They have hands-on learning activities.
My research includes both field, laboratory, and theoretical work. We've been all over the world, really, from Mozambique to the high Arctic in Canada. We've been involved in a number of interesting studies in that regard with respect to the ages of certain paleontology events, but also natural hazard work as well.
In our field schools, we teach students to do geological mapping, to use compass, to plot the geology on the geological maps, to produce the cross-sections, as well as to better understand geological processes.
Often when we're just sitting in lecture, it's hard to really integrate that knowledge in your mind of what is this going to look like in real life. So I think it's very helpful that students have this opportunity to spend 2 weeks out in the field only observing things with very little theory and most just practical application of their knowledge.
Nice.
Nice.
Oh, here we go. This is a good face too.
We're able to really focus on each student because we have small classes, we have very diverse faculty from different countries, and we're really trying to address needs of each student and help them to learn and become professional in their field.
I think what I like most about being a teaching assistant is the questions that get thrown at you that you don't expect, that make you question your own knowledge, and I'm constantly then learning through the students.
When I see that the things that I'm saying are resonating among the classmates, there's smiles, there's nods, there's nothing better than that.
You either study physics or chemistry or biology or mathematics, but in earth and environmental sciences, we actually collaborate across all of those disciplines and integrate them together to solve whatever problems we're faced with. And at the moment, our world is faced with quite a few problems, whether that be sustainability, resource use, or climate change. By studying earth and environmental science, you get to combine all of the different disciplines into one coherent vision for how we can tackle these problems. Contrast to all of the other rocks that are